So welcome to this lesson again. So this is part 4 of this AB-100 domain 3 of Agentic AI Business Solution Architects Microsoft examination. So deploying AI power business solutions is what this domain focuses on. So it focuses on operationalizing agentic AI solution or Microsoft 365 Copilot Studio, Azure AI Foundry, integrating and also managing and operationalizing on Dynamic 365, Office 365, and other platform where you deploy them. So we are looking at operate, validate, and govern. So on this first slide, we have AI application lifecycle management. So we've been talking about AI application lifecycle management from the beginning of this course, even from domain 1 to up to domain 3. Now let's look at it in depth here. So AI ALM, very important. So architecture terms that you should understand here are models. So these are your base model, LLM and SLM. You have your data layer, data architecture, either from SharePoint, OneDrive, blob storage, or RAG database, or Azure SQL database, or the warehouse, or Fabric, or OneLake, wherever the data are. Then you have your prompts. So we've looked at how you can design and validate prompts, particularly validation in the previous lesson. And then we have your knowledge sources and telemetry. This is your telemetry data, metric collection and log connection, and the analysis and usage. So these are architecture terms that you should understand here. So AI lifecycle management, or AI application lifecycle management, ALM, is just overseeing the entire process of the agentic AI system from end to end, from design to deployment to operation, and then to usage. That's AI application, and that's what we have been discussing from the beginning of this course. It's just an operationalization management of agentic AI system, metric collection, telemetry collection, monitoring, governance using Microsoft Purview, security, entire application security, setting perimeter security using Microsoft Defender for Cloud, guardrails, and the guardrails using company policy and Azure policy, and the security and least privilege using rule-based access control, data loss prevention on Microsoft Power Platform, particularly applied to Dataverse, and so on and so forth. So let's look at it in depth here. We have traditional ALM manages code, build, deploy, and monitor. So we have said several times that agentic AI system is more complex than that traditional application. In traditional application, you only have your code and your application. So, but here you have your base model, you have your prompts, then you have the RAG database. Apart from the agentic AI database, you have the RAG database that you are supplying, and then you have the entire application to manage. So traditional ALM manages code, build, deploy, and monitor. That's the entire development life cycle of traditional application. But AI ALM, on the other hand, manages code, it manages model, it manages data, it manages prompt, it manages knowledge sources, it manages the agents themselves, it manages guardrails, it manages telemetry and feedback. You can see that AI ALM is more complex and wider than traditional application lifecycle management. Okay, so you can see it's a lot of work here, and that is why it must be taken seriously, because any breach in any of this particular case study will cause the application to misbehave or to perform below standard, or to even expose the agent to prompt injection, and thereby compromising company policies and company data. So AI requires stricter governance because data drifts, model drifts, prompt updates, and knowledge sources changes continuously or alter system behavior. So any of these drifts, any of this change can alter system behavior, not only base model alter system behavior. Data drift can alter it. Prompt updates, okay, maybe or using outdated prompts can also alter or inhibit system behavior. Knowledge source, if you change the knowledge source to wrong knowledge, it alters system behavior. So this AI must be handled with stricter, control and focus than ordinary traditional ALM. Ordinary traditional ALM, yeah. So AI-ALM equals governance, versioning, deployment, monitoring, and retirement across the full AI stack. So this is what you should, when AI-ALM is mentioned, these are what should come to your mind. So AI-ALM should cover governance, security guardrail using Microsoft Purview, Azure Monitor for telemetry log collection, and role-based access control, Microsoft Entra ID for governance, and so on. Versioning using CI/CD, environment variable, and deployment using pipeline, whether Platform pipeline or Azure DevOps pipeline. Versioning using CI/CD, or source control deployment using pipeline. Monitoring using Azure Monitor or Application Insight or Copilot Studio analytic platform, or any of the platform we have discussed. And the retirement when it is no longer in use, or when it is no longer needed, because you can't use application to be generating cost when it is no longer useful. So when the agent is no longer needed, then it is retired. So across the full AI life cycle. So this is what you should say, what should come to your mind when AI ALM is mentioned. Very, very important. Governance, versioning, deployment, monitoring, and retirement. So ALM for data use in models and agents. So AI data ALM. So we have the agentic AI ALM, we have the AI data ALM. AI data ALM is the life cycle of the agentic AI system data, or the life cycle of the data that the AI agent is generating. So life cycle of the output of the model or the output of the agent is the AI data ALM. So just like, if you're a data engineer, we know we have data engineering life cycle, which is extract, injection, transformation, and loading. And then when you load, you still govern, okay, and implement access control and the rest. So that's a data engineering lifecycle. We have machine learning lifecycle as well, okay, which is a business objective, data collection, data processing. We have feature engineering, and we have model training, model training, model validation, model deployment, and the inference. So you have inference, and then you have the whole operationalize, or you have the whole operation. So every application have their own life cycle. So the data that the agent is generating also have their life cycle. So the beginning of the life cycle of AI data ALM is plan and catalog. So plan the database, plan and catalog based on the platform you are deploying to. If you are using Dynamics 365 as your integration, your agentic AI memory should be Dataverse. Okay, your state should be Dataverse. Dataverse will be used to store the context, store the output, and the entire operation. And if you are using Dynamics 365, for instance, then you should be looking at storing in maybe files or workflow in SharePoint files, SharePoint folders, Microsoft Excel on SharePoint, or SharePoint list to collect data. Then you can, if you are building within Azure, then you'll be using Azure SQL database, okay, transactional database, to collect output from the agent and to log agent data and metric. So plan and catalog. Plan the data. You say structured or unstructured. That is the first thing. Then ingest and prepare. So you ingest the data from various sources and prepare. This is if you are using RBAC database. So ingest from SharePoint, from OneDrive, from wherever the files are. Ingest the data and prepare it for the use of the AI, because you can't feed an unclean data into AI. It will cause hallucination, and it will cause model drifting. It will not make the output of the agent to be accurate, in short. So after that, you develop and then evaluate. So develop the model and evaluate the model, and then you stage and approve. So stage the data and approve it, and then you deploy and operate. So this is how the whole process grew. So you can also use in your RAG database design. I think in one of the discussion in design in domain 2, we discussed the RAG database pipeline, and it also follows something like this. So you can use this to manage life cycle of agentic AI system database. So ingest and prepare, develop and evaluate, stage and approve, deploy to production, maybe to you want to analyze using Power BI, or you want to use the output to train an output to train a machine learning model, okay, to want to present the output to CEO, CTO, or CFOs. So you deploy the data for usage using any of the platform, and then operate. So you also continue operating, continue monitoring, okay, monitor the data even when it is being used. So version training, fine-tuning, evaluation, golden test data set, knowledge bases, prompt asset, telemetry, feedback, and DLP policies are where you get the output, from. So these are what generates data in agentic AI system, and these are where all this data is coming from. So you have version training data, you have fine-tuning data, you have your evaluation data, you have your golden test data set, you have your knowledge basis data coming from the knowledge basis and knowledge sources, you have your prompt asset data that the prompt is generating, you have your telemetry data from monitoring from application insight and Azure Monitor, you have your feedback data from maybe survey or conversation transcript, and you have your data loss prevention policies. All these are generating data, and then this is what the entire data that the agentic AI system is using and also generating as well. So you can use the development or the DevOps process to also manage the AI data. So use dev test, pre-prod, and prod. So dev test, pre-prod, that's staging and prod. Okay, red gold data set. You have the red gold data set. You have data contract, which is data products and data that are already been fashioned for analysis as designed as a product. Then you have quality reports. Okay, so quality report are what you are visualizing from PowerPoint and using the data. Then you have lineage tracking. So which agent is the data coming from, and where is the data stored? So you track the lineage from source to usage, and the set evaluation gates to evaluate the data, and the residency review. So also determine residency review where the data should be hosted, whether SharePoint, OneLake, OneDrive, warehousing fabric, and what type of warehousing fabric, or on Azure if you want to use Azure Synapse or Azure SQL database. Then also determine rollback and retirement. So when the data should retire and be considered as an historical data. So it's also very, very important. So this is the life cycle of agentic AI system data. Then Copilot Studio ALM. So we are in the stage of ALM now. So all this slide will be discussing ALM. We've looked at that for data. Let's look at Copilot Studio ALM. So ALM for Copilot Studio agents, connector, and actions. And these are the architecture terms that you should understand here. Managed solutions, DLP policies, connectors, actions, and environment strategy. And believe me sincerely, environment strategy is everywhere in the question. DLP policies everywhere in the exam question. Connectors and action are everywhere, so make sure you understand them in depth. So let's look at the point here. So govern agents, connectors, actions, dataverse assets, power automate flows, plugins, external APIs, topic, prompts, and knowledge sources. All of this should be governed. Okay, so and how do you govern them? You use Microsoft Purview as your governance tool. So all this should be connected to Microsoft Purview and be properly governed. And then make sure everything here implement role-based access control. Recommended environment strategy are dev or manage. So for every or manage or products, every unmanaged agentic AI application should be in development stage. then testing. So everything that you want to manage and deploy to production should be in test stage. And then you have prod. So prod is where the users and business owners will connect and use the agent. So prod is also managed. So remember very well, please, this is part of the examination. So you have depth. This environment is unmanaged. Test environment, development of environment is unmanaged. Test environment is managed. Production environment is also managed. The next point, never edit production directly. Even in traditional application development, you do not edit production directly. You edit in development and create a pull request to staging, and then it is accepted in staging and tested. If it meets the production standard, then it is deployed from staging to production. That everything, every workflow, whether traditional or agentic AI system, should follow a proper processing pipeline, development to staging and to production. Very, very important, even in Power Platform application. So never edit production directly. Promote through environment with data loss prevention, connector policies, data residency, safety review, and monitoring. Very, very important. So connector lifecycle. So these are agent connector lifecycle. You have the author, then to authentication testing, to DLP review, to security review, to production publishing. So everything should pass through a connector. All the connectors should pass through a connector lifecycle. Very, very important. So you have the author of the connector, where the connector is coming from, maybe from Copilot Studio or Foundry. You have the authentication. Connector should be authenticated before they are authorized. Then we have the data loss prevention review. This is to set guardrail and compliance. We have the security review to check the assets that the connector have, this role-based access control, and then we have the production publishing. If it passes through all this stage up to security and it passed, then it is allowed into production. So it is allowed access, and then it access the information it needs, and then it publishes it. So the action life cycle. So agent action are a combination of tasks that the agent can perform. So action life cycle include design. So you design the action, you build the action, you validate the action, you promote the action, and then you monitor the action. So this is also ALM for agentic AI system action, or for agentic AI system that you are building in Copilot Studio. So all these are what you should understand for application lifecycle management for Copilot Studio agent. And then we have Foundry ALM. So remember, everything is a platform, and everything have their different life cycle. So the different life cycle that we apply for Foundry, that we apply for Copilot, for instance, most of them are not applicable for Foundry agent, and that is why we try to break it down as much as possible to discuss ALM for each platform that you are using to build the agentic AI and where you are deploying to. So architecture term that you should understand for ALM for Microsoft Foundry Agent Service are agent logic. So these are agent rules and principles, okay, that you can use to perform a task. Then we have promotion gates. So these are also whatever you are deploying in Foundry, every agent that you also build in Foundry should be gated, should pass through gated deployment from development to staging and to promotion. Every stage should be gated. You should implement gated deployment or gated development. Then role-based access control, very, very important. Agents must have access, and the manage identity at deployment and at production. So you also have identity and roles and role-based access control. Then rollback. So this is when the agent fail, or when it cannot it calls a tool and the tool is not responsive, responsive, should be able to roll back safely. And the reasoning quality. So how grounded is the base model, how grounded is the base model, how grounded is the base model with respect to the complexity of the task to determine the richness. So these are the architecture terms that you should understand. So let's look at it in depth here. So always version agent logic. Very, very important. It is not only prompt that you version. So version agent logic. So I want you to see agent logic as a system prompt. So the logic of the agent are the system prompts that you are giving to it. So it must be grounded, it must be fashioned, it must be accurate, and it must be within the business context and boundary, and it must be reasonable and understandable for the agent. So do not make agent prompt or system prompts too long. Make sure they are good instructions that are precise and focus on the business context. So version agent logic, version prompts, version workflow, version connectors, version permissions, and policies. Make sure everything is always version so that when they are updated, the changes will also be deployed with the agentic AI code into the production. Point number two, environment model. So the environment you should pass through, you should pass your development through dev, test, and prod, just like we have in Copilot Studio with promotion gate. So always implement promotion gate. Every process, every stage should be gated. Development should be gated, test should be gated, production should be gated. So how do you implement gate? So when you are talking about gating, you are talking about approval. So there should be someone that will approve whatever you are. When you create a pull request to push your code from development to testing or to staging, there should be somebody that will approve it before it is deployed. Then when the agent is tested in the staging and you want to deploy to production, there should be another person that will approve, a higher developer or a senior developer that will approve before it is deployed into production. So that is gates. So there should always be quality gates or human in the loop that will approve at each stage of the development. So dev to test validates functionality, safety, data mapping, and connector configuration. So you can always, at development, you can always test the functionality. You can perform functional testing, perform safety testing, data mapping testing, and connector configuration testing before you deploy to test. Then test to prod. So the testing that you should be looking at conducting here at the test stage is validate regression. So conduct regression testing, okay, conduct complier testing, conduct performance testing, check cost testing, that's a token usage and output, and then human review. Okay, so these are the tests that you should conduct here. And the security control. Security control that you should put in place include role-based access control. So as a developer, make sure you are given the right access to develop. Okay, you should have a developer role because before you can deploy in Microsoft Foundry, you should be given a developer role from the Foundry developer role from the Microsoft Entra ID. Then you need secret separation. So always separate secret from your code. Do not keep secret as part of code. Always, hide the secret. You can use Azure keywords to store secret. You can store other variables as environment variable and make sure they are not deployed with the code into production. Okay, so you can approve data only. So approve only the data that the agent should access. Do not give agent approval to access data that it should not have access to. Then solution packages, always make sure your solution package is secure. Make sure the code is secure. Make sure the entire deployment process from development to testing to staging, everything is secure. And then make sure all the environment variable and endpoint URL are secure as well. So deployment pipeline, for deploying Microsoft Foundry agent, you use Azure DevOps pipeline. Very, very important. It's part of the examination. You use Azure DevOps pipeline. And for Microsoft Copilot agent, for Copilot Studio agent, you use a Power Platform pipeline. So rollback. So make sure you process also rollback safely when something goes wrong, and then use for telemetry collection, use Azure Monitor or Application Insight. So safety is very, very important. Also make sure everything is safe by using guardrail, by collecting telemetry from Azure Monitor, Microsoft Defender for cloud for entire application defense, and the Microsoft Purview for governance and for guardrail, and the Azure Policy for policy implementation. So make sure the reasoning quality is very sound, and also make sure user feedback are secure and securely collected as well. All right, so here the next ALM we have here is a model ALM. So you can see everything have ALM, everything have their application lifecycle management. The base model you are using is also an application, and you must also govern it. You must also version it, and then you must also make sure that it follows a life cycle. So ALM for custom AI models. These are the architecture terms that you should understand here. Understand model registry. The model registry is where you register the model, the name of the model, the capability of the model, token usage, everything, top B, top K, everything. This is where you register model registry. So model registry on Microsoft Foundry is where you choose the model you want to use. You see GPT-5, 5.5, 5.6, or 4.0, 4.0, or you see Claude, Claude IQ, Claude Sonnet, Claude Opus, and so on, or Grok, Quam, any model, or Copilot itself. So model registry is where you choose your base model. Then we have the model card. Model card contains the model information, the model name, the model name, the model, the model ID when it was built, when it was deployed, when it was released. So whether it is up to date or not. So model card contains the model information and what you need to know about the model. Then we have the golden data set. So golden data set is just like the data that you want to use to fine-tune the bait model. And then we have drifting. So model drifting has to do with hallucination and changes in the output of the model. And then retirement. So you can also retire base model when it is no longer applicable. For example, if you use a simple model for a simple task and the task becomes complex, you may need to retire the base model and go for or you may need to retire the small language model and go for a large language model. So you can retire model by changing the model type. So you can change from GPT-4.0 to GPT-5.5, for instance. You can even change from GPT 5.5 to even Claude Opus, for instance. So that is retirement. Let's look at it in depth, guys. So model lifecycle includes planning, designing, data preparation, model development, evaluation, model card, deployment, monitoring, and retirement. Very, very important. So model registry is where you choose from if you are using base model. But if you want to build foundation model, then you need to plan and design it. You need to prepare data that you use to train the model. You need to develop the model using a specific algorithm from the deep learning models. Then you need to, from the deep learning algorithm, sorry, you need to evaluate the development or evaluate the model, then generate a model card. You give the model a name, you give it a version and the information or description as well. Then you deploy the model and then you monitor the model, and then when the model does no longer meet the need, then you retire the model. So this is just this is a machine learning life cycle. This can be seen as a machine learning life cycle. Building based model is also machine learning, and you have to implement the whole operation of ML ops or generative AI ops. So after that, you track hyperparameters. So always make sure you track up hyperparameters. Hyperparameters is when the model is exceeding what it should do. Hyperparameter is when the model exceed the training capability. So when it's performing above the standard of what it is designed for, then you have to conduct hyperparameter tuning. You can use principal component analysis, and then you can use any of the model or any of the principle like grid search and so on and so forth. Then you train, when you perform hyperparameter tuning, then you train the model again, training configuration. So you retrain the model again, using training configuration, curated data set. Always make sure you use curated and accurate data set. Also use golden data set, use data that are very, very grounded and have accurate metric and you can use to train. And then model versioning. Also make sure you version the model. When you retrain, give the model a new version. Then also collect model metric, observability metric to measure drifts and changes. Also measure risk, mitigate risk by protecting the model from, prompt injection, and protecting the data source as well, and the output of the model. Also set constraints. Okay, set constraint around the, model inference. Very, very important. So point number 3, evaluate accuracy. So always evaluate accuracy of the model, whether you are developing from scratch or you are using base model. Evaluate the accuracy of the model, evaluate the latency of the model, evaluate the cost. Okay, very, very important. If you are using base model, if you are using already made model like GPT, always evaluate cost, evaluate throughput, evaluate safety. Okay, safety of the model, very, very important. Also, if you are using a pre-built model, so evaluate the safety of the model, evaluate the scalability of the model. When the task become complex, will the model still be able to handle the complexity of the task? Evaluate resiliency. So how strong and reliable is the agent when it is being bombarded beyond the capability? And then also evaluate integration. So also evaluate integration reliability. Very, very important. Can the model integrate with the already made system? Can it integrate with Office 365, Dynamics 365 without any error? So it's part of what you should put into consideration as part of your management. Then the last point we have here is use model registry. So always use model registry, even when you are building the model yourself. When you want to build, when you are building the model yourself, make sure you fashion the model and keep them in the registry. If you are using base model, you also choose. If you are using pre-built model, also choose them using model registry in Azure AI Foundry. So use model registry, version releases, rollback plans, drift monitoring, audit log, archived activate, and transition plan. Very, very important. So this will enable you to, keep the base model active at all time. All right, so we are done with this section 4. I will come back, we'll continue to section 5. If you are just joining us, please kindly like and subscribe to our channel so that you receive more video from us. Thank you.